Allora, buongiorno. Buongiorno a tutti, grazie per essere qui per questo evento. Io sono Fabio Vitali del Dipartimento di Scienze dell'Informazione dell'Università di Bologna. Sono molto emozionato di introdurre una giornata di studi con quello che nei fatti è il padre storico della disciplina di cui mi occupo 24 ore al giorno, la disciplina degli ipertesti. È uno appunto dei visionari, dei sognatori, degli originatori di uno dei cambiamenti scientifici e tecnologici che ha di fatto modificato completamente il modo di percepire e vivere non soltanto l'informatica, ma credo anche la vita, la società, l'interazione tra le persone, il modo di accesso alla cultura e alla comunicazione. Averlo in Italia secondo me è un onore, è sicuramente la prima volta che parla a Bologna, è una delle prime volte che parla in Italia. Abbiamo un'intera giornata a disposizione con lui. In questo momento appunto verrà fatta una lezione aperta sui temi che caratterizzano i suoi ultimi studi, le sue ultime attività. Dopo ci trasferiremo presso il Dipartimento di Scienze dell'Informazione per un seminario approfondito e tecnico sulle tecnologie che stanno alla base di queste teorie, in particolare Xanadu e Zigzag. Volevo ringraziare sicuramente per lo sforzo organizzativo e la sponsorizzazione Spinner 2013 e Enea, che hanno contribuito economicamente per la possibilità di questo evento, e ovviamente l'Accademia delle Scienze che ci ospita. Il professor Manzoli, il direttore, è stato così gentile da fornirci questa meravigliosa sala, la Facoltà di Scienze, Matematiche, Fisiche Naturali, che ha potuto organizzare questa cosa, e ovviamente il Dipartimento di Scienze dell'Informazione, che metterà a disposizione le strutture per la seconda parte della giornata.
I am a controversial figure, which means that everybody has an opinion about my work, but nobody understands what it is. My ideas are so simple that no one can understand them, because they are not like what you have been taught. They are not like what people say God intended computers to be used the way. It's very strange what a religious feeling people have about Microsoft Windows or about the Macintosh, as if these were put there by heaven, whereas in fact they were put there by some very, very unusual people. That reminds me, my new book is called Bearing Gifts. Here's a copy of it, and that's a picture of Bill Gates when he was under arrest in Albuquerque, New Mexico in 1977. But it's the sweetest picture of Bill Gates that was ever taken. So, for strange historical reasons, we have come to a position where people think computers are the way they should be. Now, I had the strange luck of starting out when none of this existed. So I could begin to imagine it completely differently. And it hasn't worked out the way I imagined it. Now, when someone believes something that no one else believes, that is called paranoia. It follows that there are two possible cures for paranoia. One is that the patient comes to see the error of his ways and changes his views to agree with everyone else. That is the low road. The better way is for the patient to persuade everyone else. And so since now he no longer disagrees, he is no longer paranoid. There was a man who wrote a song, and he believed very much in this song, and he sang it in every town of his native land, hoping that everyone else would sing it. And finally, his song, La Marseillaise, became the national anthem of France. Well, I sing my song in every damn country and every place I go, because one of these days you people are going to recognize how strange the things are that you have been accepting, and how much simpler and better it all can be and will be. That is my belief. And I just hope to live long enough to use the systems I've been designing all these years. I won't tell you about the political problems we've had. But I think of myself as the only dissenter in the computer field. See, I've always had alternative designs for a personal computer world and personal documents. I haven't talked about that because that would have been too much to say 40 years ago. But I could never get the leverage. Bill Gates tried to get me into Microsoft, but I was too disgusted with Microsoft. And I could not find the independent leverage. The guy who did what I wanted to do is named Steve Jobs. Now, he and I are very much alike. I think of him as my dark, younger twin, because we have the same temperament. We're both very irascible and very sure of exactly how things should be. And he packaged the conventional structures of the computer world to make them look new and exciting. And he positioned Apple as a defiantly creative company, even though he was only packaging what had been created at Xerox Palo Alto Research Center. Where did Apple, by the way, where did they get the defiantly creative attitude and style of the company? From my book, Computer Lib, 1976, that was written, 2 years before, or a year before Apple was founded, or at the same time Apple was founded or something. I still think there is room for an Apple-like company built around concepts different from the traditional ones. And in the very short time left for this lecture, I will try to explain what those are. Because, you see, I believe that today's computer world is based on techie misunderstandings of human thought and human life. Here's an example. Today's car radios. Now, again, some of my best friends are techies, so the word should be technoid. A technoid is somebody who doesn't understand human beings. So technoids have designed today's car radios so that what they do best is they scan to the next station. Now, the people who design these radios obviously don't listen to the radio. They don't want to listen, they want to scan to the next station. They had it right. Car radios were correct in the 1940s. You were expecting to live in one particular place, and there may be 5 stations you'd like to listen to regularly, so you have a button for each one. It's very easy to set that button. And now it's impossible. You have to read the manual, but who wrote the manual? The techies wrote the manual, so no one can read the manual, and no one can set the buttons, and no one can use the car radio, and no one cares, except me. Because this represents the way the world is today. Look at the cameras, they said. You see, when I started taking pictures, cameras were really hard to operate. You had focus, aperture, and shutter speed. Really difficult. Yeah. And now you have aperture priority, shutter priority, red eye focus remover, and when you press the button it doesn't take the picture because it lets things settle a little bit, so the picture changes completely before the camera takes it. This is called progress. So these are the same people who are designing software today. My war with the techies began when I was maybe 9 years old. My grandfather, who raised me, wonderful man, was Norwegian, and he loved potatoes. So, and Norwegians love potatoes. So when pressure cookers were first introduced, I think 1947, we bought this big aluminum pressure cooker. And it was very heavy. And it had a big top and 2 handles. So you put the potatoes in, you put the water in, you turn the handles, and you close the valve on top, and you put it on the fire for 25 minutes or something. And then you took it off, and you release the pressure, and you open the handles, and then you take out the potato. One night, my grandfather forgot to release the pressure. He turned the handles. There was a terrible explosion. His face was covered with boiling mashed potatoes. His eyesight was saved by his glasses. His head, if it had been half an inch further, his head would have been smashed. The top of the pressure cooker made a big hole in the ceiling, a dent. And as we drove to the hospital that night, 9 years old, I was cursing the fools who had designed that piece of equipment. Because any fool should see that you must build it so you cannot open it without leaving the pressure on. Those people are designing software now. Now, Steve Jobs, you see, is not a designer. He's a director. I took a personality test once and it said, you're an independent producer-director. Exactly. The trouble is that in software it's very hard because the programmers won't follow direction. But Steve Jobs, unless you can fire them like Steve, Steve Jobs has the taste to see of all the things that are offered him. He says that, and make it bigger, and make it heavier, and make it rounder. So he has the taste to know how it will seem to the user. Steve Jobs understands the soul of the user. Bill Gates at least understands what a user is. He would recognize that a person sitting at the computer is a user. And the Linux people don't have a clue. So the point is that we are getting software at all these different levels, but it's all based on the same traditional ideas. In 1947, probably, around then, they created the first hierarchical directories. Where will we put these files? Let's make a file that will contain the other files, and we'll call it a directory. Yes. And gradually they said, well, let's put directories inside directories. Yes. And finally with Unix in 1970, they started making directories all the way down, turtles all the way down. And so this came to have a mystical significance. It seemed so pure, so perfect, so platonic. It's just wrong for human life. Because my life is not divided into hierarchies. Maybe yours is. Good, fine. You be happy. Anyone who likes things the way they are, I don't have to worry about. I want to please the people who don't like things the way they are. That's much harder. So, I always have these people who say to me, what's wrong with hierarchy? Well, the problem is that if you don't know already, you never will. Because most things don't fit in a hierarchy. People say, well, what about animals and biology? And the answer is, that's a lucky case. And by the way, that's not so clear-cut either. Armies also are hierarchical. But the categories of libraries, for example, are hierarchical because they started doing that in the 18th century. But I don't know what categories my books fit in. Yes, people tell me, oh, that's computer science. It is. So we are forcing things to be a certain way when they're not appropriate. Now, relational database, that's a good one. Relational database runs today's world. Well, it was invented by a guy named Codd at IBM. And the story I was told, haven't been able to verify this in writing, was that he had 500 PhDs working under him at IBM developing this system. And he has these 13 axioms, which of course are called Codd's 12 rules, because there's a number zero. And no one pays any attention. IBM told him he had to get a product out within 2 years. I haven't been able to verify this. And he quit in a huff. Whereupon his successor at IBM created the SQL language as a way of querying and setting up the tables around which relational database was built. Who designed relational database? Answer, one guy and then somebody else. So it wasn't the original idea of the person who created SQL, it was a mix. And it makes very little sense. Here's what I have to keep track of. I wish I could keep track of. What have I published? And where? And when? Who was the editor? Did it go with the lecture I gave? Where did I give the lecture? When did I give the lecture? Who else did I meet? Did we have dinner? What else happened on that trip? How do you divide that into tables? In the database system I will show you, you don't need to. So the point is that relationships and structures go on and on in all directions. And it is the job of data design to represent correctly the world is, the way the world is, not to force the world into the structure that is convenient for the data systems. Now, I was talking to Fabio last night, Fabio Vitali, and he said, well, you know, people have such a hard time understanding your ideas because you're telling them that everything they're doing is wrong. I'm not saying that. I'm just saying it's not appropriate for human life. And some people say, but I like things the way they are. I like Windows. I like my Macintosh. Fine. Someone less to worry about. Okay, let's talk about electronic documents. Would you like to sit down? Everyone's watching you. Oh, you're a photographer. I see. So, why, when I started in the computer field, did I have the temerity, the unmitigated gall and egotism to suppose that I could design a computer? Well, that requires a little explanation. You see, I called myself a philosopher and a filmmaker. I had made one film. Due to technical difficulties, I can't show you the piece I wanted to show. But I'd made one film, and I was very proud of it. But I'd done many projects. By the time I graduated from college, I'd won prizes in poetry and playwriting. I had acted professionally on television. I'd been on the professional stage. I had made a long-playing record, and I had written and directed what I believe is the first rock musical at Swarthmore College in 1957. And I'd published my own little magazine, which ran for 3 issues, and I later found out that that's the criterion of success in a little magazine by some people. So I never asked people how to do things. When I sat in on the organizational meetings for the official literary magazine of the college, they said, oh, we're going to have very high editorial standards, and we're going to spend $800. And I said, $800? And I went to a printer, and I said, how much to print both sides of a sheet of paper? He said, $32. That's enough. So I made a very little magazine out of one sheet of paper. It was called Nothing. We had a Dada Club there, and this was the official publication of the Dada Club. And when I later met, 40 years later, I met Victor Navansky, the editor of The Nation magazine, a very prestigious political magazine that always loses money. Since the Civil War, it has always lost money. And he said, not Ted Nelson, who published Nothing magazine. I was so happy. So, nobody told me how to do these. I just got in the habit of knowing I could design things and feeling very confident. And I called myself a philosopher because I'd majored in philosophy in college. And I called myself a filmmaker because I made a film, and I believed I could design anything and analyze anything. And so when I saw the computer, I said, hold me. They don't know what they've got. It's a media machine. Now we're talking 1960. I saw you could put a screen on it. Now there were no screens on computers, almost no screens on computers anywhere, but they were doing that in air traffic control and nuclear warning systems. But it was clear that 5 and 10 years from now the price would drop. I thought it would drop sooner than it did. And I said, okay. The human race is going to be working and reading and writing at computer screens for the rest of history. So it is my job to design the documents of tomorrow, or else the techies will screw it up. And that is exactly what has happened. Because the first question I asked was, how can documents on a computer screen improve on paper? I will say that again. How can documents on a computer screen improve on paper? Well, the first thing you can do is have every quotation connected to its original source so the reader can jump to it. And build the whole system for quotation so that anything you quote comes from the original source. And that will allow a payment system to reproduce the commerce of publication as it is now, so we can have a proper publishing system for profit and authors can be rewarded. And so the presses will participate who own all the copyrights. What has this got to do with the World Wide Web? Absolutely nothing. So my design, the Xanadu design, is basically for endless quotation, for overlays of links to any depth, two-way links, three-way links, n-way links, links which can be published separately. You say, why can't you see it? Because it's not compatible with anything else. That's the problem. You have to start from scratch. They didn't start from scratch. And what did they ask? In 1974, when those gods assembled at Xerox Palo Alto Research Center, I don't know if you know the story. In 1974, Xerox was the richest corporation in the world. And they were making Niagaras of money. And they set up a place in California called Xerox Palo Alto Research Center, quote, to design the future, unquote. Well, they did. They designed the future all right. They designed an imprisoning future, in my view. And they imitated paper. Said, oh boy, we can have pretty fonts on the computer screen. Now it's like printing your own document. We'll call it desktop publishing. Never mind that the word for that in the printing industry is layout. They called it desktop publishing, which confuses everything since publishing means something entirely different. But they imitated paper. And one of their number, named Chuck Simone, went to Microsoft. He had a project at Xerox PARC called Project Bravo, and he went to Microsoft, and Project Bravo became Microsoft Word. And another guy from there, from Xerox PARC, hallelujah, Lord. Another guy from Xerox PARC. Brilliant. I'll have to do that in the future. Another guy from Xerox PARC, John Warnock, created a system called Interpress, and then he went and started his own company called Adobe, and Interpress became PostScript, and then it became that prison called Adobe Acrobat. And so now we have paper imitation, except what? Except paper imitation, you can't read from the screen unless you have eyes that see very tiny print. Paper imitation, now a real paper you can write on. You can write marginal notes. You can write comments. What happened to that? That's what I'm trying to do. You can, with real paper, you can put sticky notes on it. What happened to that? Answer. They didn't imitate paper really. They imitated paper under glass. So we have less than we had before, and they say it's perfect and paradise. And I say it's crap. We need to be able, all the things you need to be able to do with a computer, you have to write on a piece of paper next to the computer because you can't do it on the machine. Because those geniuses who designed Microsoft Word, see, you can only understand Microsoft Word historically. Here's how it worked. Someone goes to Microsoft and they say, I've got to get my $1 million. That means staying here 2 or 3 years. I got to work myself up, my way up, and then they get to Microsoft Word and they propose something like, I'm going to make a footnote spelling checker. Yeah, okay, go ahead. And they make the footnote spelling checker, and their stock is vested, and they get out with their money. But it has nothing to do with the previous structure of Microsoft Word. Nothing is ever redesigned at Microsoft. It is simply added to. So everything gets stranger and stranger. Now we have dogs that look things up for you, or that wag their tail while the same old search function is happening. And we have talk balloons that come up. And people keep trying to think of more things to add so they can get their $1 million. Now, is this the way it should work? My background was in philosophy and filmmaking. I tell you, it's a philosophy machine and it's a movie machine. Why is the computer a philosophy machine? Well, what is philosophy? Philosophy is about the design of ideas, and especially the directions of generalization. And when you design a piece of software, do I have time? Yeah. When you design a piece of software, you're implicitly deciding directions of generalization, ways it can change, ways it can evolve. So it's a philosophy machine. And it's a movie machine. What is a movie? A movie is a series of events on a screen that affect the heart and mind of the user. What is interactive software? A system of events on a screen that affect the heart and mind of the user and interact and have consequences. So what is your best training for interactive software design? Disney, Orson Welles, Pudovkin, Hitchcock. It's about emphasis. Now there's a so-called branch of computer science called HCI, supposedly human-computer interaction. I think that should stand for human construct interaction, because the computer has no nature. All the nature of the computer is the artificial constructs we imagine and put on the computer. So, designing the constructs and how people will interact with these imaginary constructs, that's what software design is about. And those constructs, the design of the construct is philosophy and it's filmmaking. Now, I would sum this up as saying it's presentational art. Now, you can give a person a degree in HCI, and you can give a person a degree in portrait painting, can't you? But does that mean they're a fine artist? If a person has a degree in HCI, does it mean he can design great software? Not necessarily. Because what is it about? It's about emphasis. It's about showing things to the mind, and about what things to hide and what things to shout. That's not technical. That is presentational. So the arts of presentation, filmmaking, writing, editing, lecturing, making diagrams, these are the heart of presentation on the computer screen. But that's not what you're taught. You're taught that it's a branch of blah, 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 which begins with hierarchical directories, which is very unfortunate. Okay, so now you've sat long enough, you deserve now to be shown something. I'll show you two things. I said before that we want documents to connect to their original quotations. And every quotation connects to its original source. We want to be able to overlay them with many links. And you say, how could the user imagine that? I've had techie types say, oh, the poor user, it's too complicated. Never mind, leave that to the film director. We'll work out how the user will see it. The real issue is to design the structure so that it's consistent, so that it scales, so that it's clean, so that it's a good structure, and so I will show you that structure now. So we call this analogical structure, meaning that it consists of both links and transclusion. So a transclusion is a connection between the original, between two versions, between two instantiations of the same thing. And a link is any connection put on top of it. And this distinction is vital, and most computer guys refuse to make it, and that's where it all goes wrong. Okay, so let's see this now. Here is, if I can find the right function key. Is it 5? No. Is it 7? Maybe. Yeah. Okay. Let's see it in front of me too. Here we go. Here's a three-dimensional system of documents where we can see 9 pages, pardon me, it's one document with 9 pages. 9 pages in the background and 2 in the foreground. If we had a proper gamer's machine, a proper speed, we'd be able to see this in its full beauty, but you can see all the connections between the separate pages as we fly through the structure. It's kind of like the projector of a movie in a movie theater. Now, what is the point of all this? The point is, what I need to show you is how the user can find a way among all the different connections and yet remain clear-minded. So here on the left, I wasn't aware that this was going to be so tiny. Here on the left is the current page. And that is larger type, which on a proper machine you would see larger. And here on the right is the companion page. I just made that the current page. So between the current page and the companion page, we see all the connections that exist. And as I go down in this space, new pages sweep up to join it. Again, on a proper machine and with a proper gamer's machine running on the Xbox or the PlayStation, this would be sensational, but it's a prototype. So I can step between the different pages. Now I'm on the right-hand one. As I go down in the main page, which I just wrote to show all these connections, the others leap to the foreground so that following one connection at a time, we can jump to each link or transclusion. So let's go back and see how that works once more. So I'll fly in, and we see. So I'll tell you what it says. Here's a quotation from the Bible. It says, "In the beginning God created the heaven and the earth was without form and void." And what is that from? Well, it's from the King James translation, the English King James translation of the book of Genesis, and let's go over there and see the original. So this is how we show every quotation connected to its original. This is how we show it. Now the mechanics of how we do it are not for this particular audience, but we'll be talking about it in the afternoon. So the point is that this is a principled, consistent, and powerful system of text that has nothing to do with the way documents are represented anywhere else in the computer world. The tradition in the computer world is that a document is a box of virgin characters in the sequence they're about to be presented, sometimes mangled with markup. And that markup can be fonts or pointers, but they have to be one-way pointers out as in HTML, because since they're embedded in the file, they can only point out. All this I challenge. Why is a document in one file with a short name? Because of the traditions of file structure and not because of the traditions of documents. See, technical guys would say, a document is a file which is blah, blah, blah. And I say, a document is a system of ideas created by minds for presentation to minds. Represented however best they may be represented, and presented as best they can be presented, and finding a principled representation that will handle all the possible structures of interconnection is the issue. Not accepting the notion of one-way hypertext between little pages. The notion of hypertext I'm talking about is huge hypertext. So you can create a history of the world, and you take histories of, parts of histories of Rome, parts of this or that, and you reinterpret them, and you have a table of contents which is a parallel page and leads to all the others with transclusions between it, and you have every path to all the originals, and you have anybody able to follow it and rebuild their own version easily. And so change is evolutionary and progressive, or adversarial, but continual, without having to restart, rename, reposition, and all the junk that goes with the traditions of file structure as we now know it. Now, yes, we have to deal with files underneath, but the point of making those details of the technicalities go away, rather than bowing to them, rather than fetishizing them and accepting them as defining the notion of human documents. For something lighter, let's talk about database. I spoke of database that doesn't have boundaries. Database that isn't divided into formal tables which have to be redefined every time you think, oh my God, I left that out. Database which can evolve day by day without radical change, without renormalization, without all the stuff you have to do with the system called relational database that wasn't designed by anybody and we're stuck with. So, clear your mind, and we will travel now to a world. Oh hell, I'll do it on the other machine. Well, if I do, that'll take. I'll show the movie on this machine while I fire this machine. Oh, this machine is fired. So I'll begin by showing you just a trace from my colleague Adam Moore, who did a wonderful job in using this system. The system is called hyperthogonal structure. So orthogonal, means at right angles. In how many dimensions? Well, that's the question. In hyperthogonal structure, everything can be right angles in as many dimensions as you like, and you can create new dimensions anytime you like, and the different parts don't have to match. So you can have two rows of columns that are parallel but different lengths and yet connected side by side in different orders. So, we'll go through that quickly. I'll show you what Adam Moore did with this for chemistry. Now, I don't know anything about chemistry, and I'll assume that some of you don't know a lot about chemistry, which is fine, but I want you to see what, hello. I want you to see what one very clever chemist has done with this system. The problem is, like some people, when something doesn't work, I keep clicking. This is not good. Now, for those of you who design software, I'm writing a book called The User Arrives Running. If you think a user is going to read a manual and bathe in your ideas, you're wrong. Software has to be like a 6-gun. You pull it out, and you pull the trigger, and it has to work the first time. Think of your typical user as somewhere between Homer Simpson and Donald Duck. So, simplicity is the key. The FAT filing system, which mine is full, unfortunately, and that was designed, of all things, by Bill Gates himself. Oh, here we are.
I'd like to show you something about how we're using ZZ structures to represent.
It turned out there was no audio in this room, so.
So here we have ZZ structure for bioinformatics with 4 top-level lists. We have a list of structures.
So starting with the least complicated first, we have a list of people. This is a double alphabetized double rank of values. So we have D.H. Ullendorf.
I'll explain what's happening in a minute.
Massimo Malcavati, and so on. We'll come back to where these people appear later on.
I'll just go to the climax of this film where he shows you.
Next thing I want to talk about is a list of, will give us cholesterol.
There is something in chemistry called the Krebs Cycle. And Adam shows the Krebs Cycle animated in this system. And it's quite remarkable because all it is, it's just in the zigzag system raw.
Alpha-ketoglutarate. Alpha-ketoglutarate. Add a CoA NAD plus, you get NADH, a proton, carbon dioxide, and succinyl-CoA.
Sorry.
Here comes the energy step. Succinyl-CoA we combine with water, phosphorus, and ADP, and we get out energy, ATP, and CoA. Now, of course, the CoA, as we know, is an input into the alpha-ketoglutarate. So this is a small cycle within a larger cycle, so we get CoA, NAD+, succinyl-CoA.
Now, that's all done in the database system Zigzag, including the visualization. A number of visualizations have been discovered in Zigzag that we didn't know would be there. I designed the basic system and the views, but I didn't know all the ramifications and consequences. This is the fantastic thing about a productive system of premises where you actually get things out that you didn't expect. Here's the interactive system called Zigzag, or which is an instantiation of hyperthogonal structure. This particular version was done by a group in Finland, and I think it looks really nice. So here we are seeing different views and different structures as we wander through this list of famous kings and whatnot. And we find other structures I don't have time to tell you. But the premises are extremely simple, and it's just that the cells can be connected in as many dimensions as you like, and you can create new dimensions with any names you like at any time, and the consequences are really amazing. Why didn't the other computer scientists discover that? Now, I never used to call myself a computer scientist. I called myself a philosopher and a filmmaker until Wendy Hall, who's now the president of the ACM, said, "But you are a computer scientist." Oh, okay. But why didn't they discover this? You know the story about the drunk who's lost his keys and he's looking for them under the streetlights? Well, where did you lose them? I don't know. Why are you looking under the streetlights? Because it's easier to see there. Why don't your regular computer scientist types discover things like this? Because they're all looking under the street lights. They're all following each other around, copying one another, rather than thinking about the way the world should be. I'll stop there. Thank you.
I have a very generic question.
Yeah, but you probably already know the answer. That's not fair. Go ahead.
Among the institution you criticized for not doing the right thing.
Did I criticize institutions?
Well, computer scientists and computer science and computer companies and so on.
Oh, that, okay.
Yeah. You didn't mention universities. Is that because they are irrelevant or because they are good?
I meant to talk about education. As a boy, I hated school absolutely from the age of 5 to the age of 15. I didn't hate my teachers until I got to high school, and only a few of them. But I just hated the institution. And school is a way of making every subject uninteresting. An institutional system of taking away all the joy of learning. And so it's a system of ruining different subjects for you until the last subject to be ruined determines your profession. Now, when I got to college, suddenly it all changed. And there I was in the great debates of history and philosophy and genetics and whatnot, all happening in every direction. And the excitement of being able to take courses on every subject. You know, I take one course on each subject and say, no, that's not for me, go on. But that's getting an education, right? And that kind of excitement and choice is denied to children. The opposite. Education is punishment. So one of my first instincts when I started was, how do we smash the educational system? And I don't talk about that very much, but it's still emotionally part of my making.
So college is a good institution then?
I'm not saying good or bad, except for children learning. Okay, thank you again.
Thank you.